Welcome to Hope Academy. My name is Mr. O, and today I'm going to be covering a concept called the Rational Root Theorem. Okay, so I shall write that down. Rational Root Theorem. But before I continue on and talk about different types of, like how to do the Rational Root Theorem, you have to also know that another name for this concept is called the Rational Zero Theorem. Okay, and this is exactly the same exact rule and concept and whatever not. It's just that a lot of times when we talk about this type of theorem, there's a lot of different names for the same thing. Another thing that's very similar, just as much as the term root and the term zero exists, another exact term that could exist is called the X-Intercepts, as you would see it sometimes that comes out. And so be aware that whenever we are looking for this theorem, the end purpose is for us to help us get the X-intercept, or potentially sometimes even just what we'll call the factor or factors, depending on how many there are in that question. So be aware that these are just different terminologies for the exact same thing in the very end. And so be aware that when we are going through this problem and such, be aware that this could be found for any one of these possibilities. And so when I am doing this type of concept, there are other things you do have to also side note that are not per se directly pertaining to implementing this rule, but in order to find out all the possible zeros or all the possible things, there are other concepts you do need to make sure you know. Either you need to know what we call the long division, or synthetic division will also work. Both are perfectly fine, but make sure you also know these concepts. We do have videos on these concepts already, so feel free to watch those videos and review them in case that you do not know these concepts off the top of your head, okay? And so this is how it works. So the rational root theorem or the zero theorem usually is applied to what we call polynomials, okay? And so when we talk about polynomials, what we mean by this is that it's any sort of function that has multiple terms. So for example, it could be like x to the fifth minus 2x to the fourth plus yada 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 plus like 50, okay? And the idea is that it's multiple different terms that do exist that would exist for this equation, okay? And we need something like that in order to implement the rational root or zero theorem, as we would call it. And so I'm going to go ahead and get started on a problem to show you how this theorem works and how to go about, using this theorem to your advantage. So I'm going to go ahead and write down a problem that's pertinent to this concept. So let's say that the problem states this. Let's say that it's going to be f of x equals to 5x cubed plus 29x squared plus 19x minus 5. It's going to look something like this. And so how the rational root theorem or the zero theorem works is that I'm going to be looking at the very first term and the very last term, okay? And I'm going to label them P and Q. The reason for this is that we don't care about anything else that's going on in between when we're doing the rational root theorem. We only care about these two just because there's a relevant equation that exists in order for us to be able to do these problems. And the equation looks like this. It's going to show you, actually I'm going to do it in this color, Q over P. And so in other textbooks, they might switch the variables and whatever not, but it's always the back terminology right here to the front one. And what's going to happen is that I'm going to look for all possible terms that exist for 5. Because there's a 5 here and a 5 here. So if I think about all the possible factors or terms for 5 or multiples of 5, I know right off there's going to be 1 plus minus 1 and plus minus 5 for Q. Because if I think about it, only 1 times 5 will exist. And be also aware that this could be also relevant to negative 1 times negative 5. And thus why I wrote these values. And since P is also exactly going to be the same value, I'm also going to write the exact same thing. Plus minus 1 and plus minus 5. And so these are all the possibilities right now in this equation. But afterwards, when I'm writing all the possible possible roots that exist based on the rational root theorem, I have to be aware that I need to make sure I do the fraction systems correctly. So for example, what I mean by that, I'm going to first do 1 over 1 right here. So 1 over 1 will be 1. So I'm going to write plus minus 1. I'm going to also do 1 to 5. So 1 over 5 will be plus or minus 1/5. But to continue this sort of system, I'm going to switch to also blue to show you. I'm also noting that there's 5 over 1, which is going to be 5 over 1 is just plus minus 5. And there's going to be 5 over 5, which is also going to be plus or minus 1. So be aware that because I already have one right there, I do not need to rewrite it. And so this solution that I have in front of you will, and I'm going to go ahead and get another color out. This solution right here is going to represent all the possible roots. And I'm going to write that out. Possible roots, or you could call it zeros, roots, zeros, etc. Okay? And so this solution right here is going to represent that. But there's a key word in here that I must emphasize when you are doing this problem, and it's the word possible. When I say possible, that means that these are all possibilities of zeros or roots and whatever not for this equation. It doesn't mean that these are the actual roots that will exist. And so going back to the concepts that you need to know, there's also one other key concept that I must emphasize that you must need to know in order to do this, to continue on to do this in an efficient way, to solve for all the possible zeros. And this key term, this key concept called the remainder theorem. And the remainder theorem, and I'm just going to go back and write this out, theorem. So the remainder theorem is very useful also to note, and I wanted to also include that in there because now I'm going to use this theorem, remainder theorem, which I do also have a video on, in which I'm going to use these in order to help me solve what could be a possible root. Okay, and so I'm going to go ahead and get another piece of paper out, and I'm going to show you what I mean by this. So by using the remainder theorem, okay, and I'm going to try to show space and whatever not, and I'm going to copy down the exact same equation that was from previously. So the problem currently right now is I'm trying to find all the zeros or all the zeros of this equation. So I'm going to write it again. Plus 29x squared plus 19x minus 5. Okay? And so when I am looking for all the possible zeros for this equation, the thing about this is that, as I mentioned before, these are my possible roots. And so using the remainder theorem, and I'm going to write the remainder theorem here, I'm going to try to find at least one root for now. Okay, so remainder theorem, it's time for me to do that. Okay, so the remainder theorem, I'm going to go ahead and do so. So right now, the first one I'm going to try is positive 1. Because why not? Because when I plug 1 to here, I could try to figure out whether or not that's a possible value. And so I'm going to go ahead and do that. So I'm going to write 5. And duly note that because this is in green, I'm going to write 1 into this. So 5 parentheses, and I'm going to differentiate using colors so that it helps you make it easier to follow along. 1 cubed plus 29 squared, and I'm going to write the number in afterwards just to make it easier for you guys to visualize this. So it's going to be 5, 1, 1, 1, all these wonderful things, okay? And so what's going to happen is that when I try to compute this value out, this is what's going to come out. This is 1 cubed is just 1, so it's going to be 5. Plus, since 1 squared is 1 also, it's going to be 29 plus 19 minus 5. The remainder theorem basically states that when I add these possible values, when I plug in one of the possible roots into here, it must equal to 0 in order to be a root, or an X-intercept, or a 0 and whatever not. And so for this equation, the fact is that if I add this all up, it's not going to equal to 0. So it is not a root. So 1, basically I'm going to write it in the green so you can see that 1 is not a root. Okay? And so that means I still have to do some work to find a possible root that's going to help me out. So I'm going to continue on, and looking back in the original, the work I did to find possible roots, I see that there's also a positive one and there's also a negative one. And so I'm going to go ahead and do the same thing again. This time I'm going to plug negative 1 into the equation to see if it's going to work. So 5, and I'm going to write the shells out for real quick. 29 plus 19 minus 5, and I'm going to this time plug in negative 1. And so I'm going to go ahead and do so. So this is going to be negative 1 this time. Negative 1, and see what happens. So if I do negative 1 cubed, remember that because of the negative number rules, it's actually going to be negative 1 times 5, which is going to be negative 5, plus, and negative 1 squared, when it's an even power, negative 1 squared is going to be positive 1. So it's just going to be 29, and then negative 19 here, minus 5. And so what happens is that if I actually do the computation right here, this will become, and I'm just going to show you, it will become 24. This will become negative 24, which is going to equal to 0. And so thus, I know the fact that negative 1 is a root. Okay, negative 1 is a root. And just to indicate, since the first one was not a root, and I'm going to move this up, I'm going to put an X right here, and it's going to put a check mark here. Okay, thus now that I found that negative 1 is a root, there are other possibilities that exist for me to find the roots. Be aware that even though the focus of this video is on rational root theorem, which means that I'm looking for possible roots, I'll also show you how to find the actual roots afterwards. And so after I did this work and I found that negative 1 is a root, this is the next step that I need to take, or another step that I could possibly take in order to solve it out. Okay, and so I'm going to go ahead and do so. Since, once again, I'm going to write down the original question, which states f of x equals to 5x cubed plus 29x squared plus 19x minus 5. The next step for me is to take this negative 1 root that I got and to manipulate it so that I could find other possible values. And so what I'm going to do actually is that I'm going to understand that because negative 1 is a root, I know that one of my possible answers, and I'm going to write this in red, is this, x equals to negative 1. This is one of my answers. But because this is one of my possible answers in there, there are also other possible roots that I need to find, and I'm going to manipulate this value. Since I said x equals to negative 1, that means that if I do plus 1 to this, x plus 1 will equal to 0. And this means that this segment right here, this segment right here is going to be very useful for me. Because now what I can use this x plus 1 for is that I could divide this value with this in order to find out what will be other a new equation, basically, a new polynomial that has whatever is left for potential, equations to use. And so this is what I'm going to do. So I'm going to use the long division formula, and be aware you could use other methods and such to solve it out. But right now I'm going to implement the long division to help me find all the possible other roots, real roots that could exist. So using long division, what I'm going to do now is that I'm going to divide. So I'm going to take 5x cubed plus 29x squared plus 19x minus 5 divided by, and it's going to be x plus 1. And I'm going to go ahead and divide now. So now I know that this times a certain value is going to be 5x cubed, so it's going to be 5x squared. And so I'm going to go ahead and compute that, 5x cubed plus 5x squared. If you're not sure how I'm doing this exactly or need a more thorough explanation, there is a video on this, so feel free to reference to that. But I'm going to continue on and do this work. So right here, 29 minus 5 is going to be 24x squared plus 19x minus 5. And then this is going to be plus 24x. So 24x squared plus 24x, and I'm going to subtract these, and so it's going to be negative 5x minus 5, so it'll be minus 5 will be negative 5x minus 5 will equal to 0. Okay, and so that means that when I did this whole computation, okay, if you notice, it's going to end up being the complete solution, the work and whatever not is shown right here. And so that means that this equation right here, and I do want to note this part right here is whatever is left over currently from that one factor that I pulled out of the original equation right here. This is what's left. And now I have to also be aware that after I get to this situation, I need to note that the way I'm going to get the rest of the zeros is by factoring. I need to factor this. Factor this. Because the only way now for me to get to the final solutions is by factoring this. And then that's going to help me get to the solution. So I'm going to go ahead and factor that real quick. So on this equation right here, now I note that, and I'm going to write down right here, it's going to be 5x squared. That's what's left over right now. Plus 24x minus 5. And so I'm going to go ahead and factor this. There's a lot of different methods to do this. For me, I don't really have a specific preference. So I'm just going to use the box method that's been used a lot in the classroom. So I'm going to do this. I know this value right here, these two values I'm going to represent right here under the box as 5x squared and I'm going to represent this as negative 5. And so I know that right off that this is going to be 5x and x. So it's going to be x squared and whatever not. I also know that my goal is to try to find the multiples that these two will add up to 24. So that's my end goal right here. This will add up to 24. And so I need to think about how I'm going to go about doing that. Well, I think that if let's see. So if I put 5 here, this will be 5. No, that's not going to work. But if I put plus 5 minus 1 here, let's see what happens. So it's going to be 25x, and this is going to be negative x. And this right here is going to end up being 24x. So I know as a fact these are going to be my factors. So this will become 5x minus 1 and x plus 5. But I'm not done because I want the zeros. And so in the end, I'm going to do is make each part equal to 0 and solve. So plus 1 divided by 5, x equals to 1/5, subtract by 5, x equals to negative 5. And so now these are all the possible solutions that do exist now. So I do want to note, and before, from the prior question, we already told you that this was one of the solutions, x equals to negative 1. So I'm going to rewrite that right here. So one of my solution is going to be x equal to negative 1. Another possible solution now is x equals to 1/5 and x equals to negative 5. And these are all the answers to the real roots, the real roots or just roots for the polynomial. So to recap from before what I did, the rational root theorem was for the purpose of finding all possible roots. But in order to find the actual roots in the very end, you actually need to use other rules that could exist. And so be aware that this is, in my opinion, the faster method where you could actually, from finding one possible root, pull out that root from the polynomial and then factor out whatever's left for this scenario. So because I knew this is x squared base value, I could factor it out and solve it out. For more complicated base polynomials, and I do want to side note this, for more complicated base polynomials, it might not be as easy for you to do this type of method. And so another way you could do these problems in the situation that is not as simple is that you actually will use the rational root theorem multiple times in order to find all possible roots that could work, and then try to simplify it from there. And so I'm going to demonstrate a question, and I'm going to explain a little less this round. And this time I'm just going to go through the problem and actually show you how I would do the problem, straight out. And so I'm going to go ahead and do that and clear all this. So now the problem states this, and on this one I cannot get away with just factoring right after doing a one rational root. 2x to the 4th minus 9x squared plus 7, okay? And so first step, rational root theorem tells me I need to find what are the possible multiples of this and this. And I'm going to call them P and Q. And once again, Q over P, as I mentioned before, I'm going to find out it's going to be plus minus 1, plus minus 7 for that. It's going to be plus minus 1, plus minus 2. And so, and I do the crisscross and whatever, now it'll be plus minus 1, plus minus half, plus minus 7, and plus minus 7 over 2, which is a decent number of these possible values. Now my next step is to plug into the equation. So using different colors so that you can see what I'm doing. I'm going to copy this equation, but I'm going to start with 1 now. So 2, 1 to the 4th minus 9, 1 squared plus 7. So it's going to be 2 minus 9 plus 7. And it's going to actually equal to 0. So 1 is a factor. Okay, I need to note that. And let me continue. So let me find another one, because even if I divide 1, this equation right here, the x to the 4th, will only become x to the 3rd. So I can't factor that still. X squared is the most factorable for me. And so I'm going to plug in negative 1 now. So negative 1 to the 4th minus 9, negative 1 squared plus 7, which is going to be 2 minus 9. Oh, wow. It actually ends up being also 0 for this question, because even powers will cause it to become a positive value. And so that's what's going to happen. So I know this one also works. It doesn't always happen that the values lay out this quickly, but for my case, that's really fortunate because now I could actually now divide twice and get the x squared value in order to make my life easier and now factor. So now that I have the values that I need, now I'm going to go ahead and factor, as I mentioned before. So I'm going to do is using a different color, I'm going to divide. So 2x to the fourth, which is the original question, minus 9x squared plus 7. And now I'm going to take one of these. So I'm going to use this 1. Remember, this 1 is going to be equivalent of x minus 1, basically. So this is going to be my x minus 1. And so I'm going to go ahead and divide. So it's going to be 2x cubed. So it'll be 2x to the fourth minus 2x cubed. And be aware, because there is no x cubed term, I'm going to just bring this down, make it 2x cubed minus 9x squared plus 7. And then what's going to happen is that it's going to be plus 2x squared. So it's going to be 2x cubed minus 2x squared. And subtract. These cancel out. Plus 2. So negative 7x squared plus 7. And then so continuing on, and I'm going to get more scratch paper for this. So to continue on with my division, I'm going to move this off a little bit. So just continuing on. So up here, it looks like since now I'm x squared, I'm going to go to minus 7x. Yeah, it looks like that. So minus 7, so negative 7x squared plus 7x. And because it's subtracting or whatever not, this will be negative 7x plus 7. And I'm just going to show the work. I'm going to move this up for a moment. So now that I have this right here, it's going to be minus 7. So negative 7x plus 7. And look at that. It's going to be 0, which means that it is a possible factor. So this process I did in the pink is representing all of this work right here. This is the work I did division-wise to find this, or aka the one part to simplify. But now that being stated, I'm going to now in different color, let's take this as like sort of like a peach color or orangish color. I'm going to do it again, but this time, because this is negative 1, this is the same thing as me saying x plus 1. And so now I'm going to do the same work again using this equation that I found in the pink. Now I'm going to divide again. So 2x cubed plus 2x squared minus 7x minus 7. Now I'm going to divide it by x plus 1. Okay? And so you'll see what happens when I do this. So I'm going to move it up so you can see what I just wrote down. Okay? Now I'm going to divide this. This is from the pink, the result from the pink. So 2x squared will be 2x cubed plus 2x squared. Subtract, these both cancel out. So it'll be negative 7x minus 7. So let's say minus 7. Okay, negative 7x minus 7. Hey, look at that. It's going to be 0 in the end. So now my leftover is 2x squared minus 7. And now I need to figure out how to factor this value out. Okay, and that's where the work will come in, where I need to start factoring and figuring out what possible values will exist to make this happen, this sort of thing. But that being stated, for this type of question, I realized that you're going to end up having to do a quadratic formula in order to actually get the final answer for the possible zeros. And so for this type of question, because I'm looking at this, I won't be able to cleanly factor this out. And so this question does become more complicated. But then the end purpose is just to be aware that we could end up getting to this situation, the x squared, and finding all the other possible values. And so be aware that currently 2 of the possible answers are x equals to negative 1, x equals to 1, but there are going to potentially be 2 more answers, 2 other answers that exist for this question. But that being stated, I just wanted to show you for today how do we set it up so that we could solve for that. And that concludes my explanation for today. Thank you so much for watching this video. I'm going to continue to improve the content and build content like this. So feel free to subscribe to our YouTube channel, like our Facebook page, or please also now follow us on Twitter. And we have just created an account for that. So thank you so much for watching this video, and I hope you have a wonderful day.